We are live from the Notre Dame IrishSat. This is our first big launch. For those of you who have been sticking with us for the year, you know that we launched the subscale earlier in the year in April. And so we're coming back for our first full-scale launch ever. Today, we're launching from Whitefield Park, which is just north of the Notre Dame campus. We have two payloads today. So the first one is named Iris. It's a technology demonstration from Professor Bernstein's lab. He does research in nano technology, and so we're launching a couple of nano antennas, which are infrared sensors. So these are funded by NASA to be eventually put on satellites to study solar physics. So this is a first step towards that ultimate goal, and we're doing a technology demonstration of these sensors in an operational environment. So when we hit our peak altitudes from 25 to 35 kilometers, we're at about 1% of the Earth's atmospheric pressure here at the bottom of the atmosphere, and we had temperatures around negative 60 degrees Celsius. So all the things that this technology needs to be able to do in low Earth orbit to study the sun are similar things that this has to do to be successful today on today's launch. So we can get a nice view here of our first payload, Iris, just being finished up. A recent switch to electrical engineer, Lindsay Falk, is getting the ropes tied up to be out to our boom system. So a relatively novel system here. We have both an active and passive orientation system. So these, as we move, especially through the jet stream, there will be up to 100 knot crosswinds, and these sensors have to be oriented right on the sun. So you can see that we have two cones here. Each are equipped with sensors, one of which will be looking just straight through the atmosphere to calibrate the sensor, and then the other one will be oriented right on the sun. And so in order to stay with good precision, we have these booms which act to increase the moment of inertia of the system, as well as an active orientation system, which is rotating on these planetary gears to keep it oriented on the sun. So that's what we got going up there. We bring it to the top of the payload, where we have Megan and Owen working on attaching the balloon. So Owen, what can you tell us about this balloon?
It's a big boy. It's 3 kilograms of latex, which is double the size of the last one. That's why we have 2 full tanks of helium.
2 helium tanks.
Yep.
So we actually have a crewed launch today. Not only do we have some great science and technology demonstrations going up, this will actually be ND IrishSat's first crewed launch. So stay tuned for those great views, getting the Earth's horizon shot, as well as Notre Dame's next astronaut. All right, we're gonna sit you down here for those viewing. You'll get a picture of Iris getting finished up, and we'll be back in about 5 minutes to talk about our next payload, Icarus.
Yeah, let's do a long break. Oh, yep, thank you. I guess we can just have people hold it up. That's probably the easiest.
So how exactly is this?
These can be used for pushing as well.
That'd be cool.
What if this table over there? Something starts
Six meters per second.
Can someone get their hand, like keep their hands on it?
What's up? Feel free to take my phone. Hey, anybody want to run the live stream right now? I told him back. I would be back in 5 minutes. Where's the phone? It's on the table. Yeah. Prop that up.
Oh, it's right here, right in front of it.
Sorry, that's the kind of stuff that needs to happen. Give me 2 minutes and then you can do that. Can someone, Will, can you toss me the roll, please?
Peter, are you doing anything right now? All right, could you come and change over this?
Yeah, it'll be T minus.
There we go. That's what stress testing. No.
Okay. This to this to
Put battery in. Zach, I didn't really, sorry, Megan.
do you want me to take over this?
Seems we need to be input.
It does. Yep. 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 Try, yeah, just keep them separate. Sweet. Thanks for.
Almost all the market.
That's. Yeah.
Hey, is the spot trace on?
Yes, on and working.
You got that APRS tracking?
Yeah, I'm hearing signals from it too.
Are you giving good commentary for the live stream?
Not yet. All right, guys.
Alright, you guys
This is
are ready
the
for
Icarus satellite.
Sure.
This is the muon detector.
Yeah, so our secondary research payload here are they're twin muon detectors. So these are developed by a graduate student, now a postdoc at MIT. So we're doing some particle astrophysics is technically what this is doing. So when we're the sun produces a lot of they're essentially like protons streaming at the Earth. They're also beaming at us from the center of the galaxy. And when these hit the Earth's magnetic field, a lot of them are deflected towards the poles, and those create the auroras. However, some of them actually penetrate into the atmosphere. And there are collisions with the atomic nuclei of the molecules that are in the Earth's upper atmosphere. And when those protons hit, they decay into more fundamental particles, some of which are called muons.
Yeah.
Sorry.
So that's what we'll technically be detecting today. So there's you can see the two black squares here. Those are called scintillators, which essentially catch the muons and turn those particles into electric current, which we can measure. And so what we hope to see is as we increase our altitude, we'll be seeing more and more muons as we're getting closer and closer and actually pass through the region of the atmosphere where they're formed. So pretty cool particle astrophysics going on, and just some of the great research that IrishSat is doing.
You can try this like
It's like a glove.
I know, I'm thinking about what, because a lot of the so you just gotta, it doesn't have to be.
Not
So this one goes under, this side goes under
okay.
It just kind of marks really on that.
Yeah.
Okay. Great.
Can you just, I'm about to switch these.
Careful with these strings now.
Yeah, I think that one.
Sorry, I just need the exact time that these are
Yeah, under.
Is this?
Like down to the second.
Yeah,
that'd be
the one you just had needs to.
so I'll just
I think it's okay. It's okay. Yeah. Just be careful.
let me
Please
know.
just find
Let me,
something.
yeah, let me know. So I can and
Exactly.
then I'll write it down here.
That's how much I hate strings.
All right. It's 11:05. 50 seconds. So if you want to start at 11:06, I'll just tell you that.
Okay.
5, 4, 3, 2, 1. Start.
Okay, what was that time?
11:06 exactly.
It's 11:06.
We'll say 11:06:05. That's what I saw the blink. So
Bye, James. Congrats on finishing
See you,
college.
James.
What?
So Lindsay's tying up Icarus.
Where are you gonna leave the mic?
So this side goes directly under that. Set next. Let's go around.
so the muon detectors have been started. So
What is this stuff?
not do that.
Right.
Yes.
Set up dial.
Yeah.
I think
Okay, we're back here. What are we doing here, Lindsay?
okay, can you issue your foot? I'm attaching Icarus to Iris at the moment.
Wow,
Yeah.
so
Vital
the payload train.
trade confusing since
How many miles of cord do we have here?
too many. You know what I mean? There's, I think it's
Oh, yeah,
like 7
how many
meters per
kilometers?
section, and then there's 8 per, yes, there's 16 total, plus there's all the horizontal ones. So we have far too much.
Let's see. A lot of cord connecting these. So seven meters between each boom. So
Not between.
Oh.
Between, yeah.
so the layout here for those of you who just are joining us. So we have our top boom here, which is connected to our 5 kilogram balloon, which is in the process of being filled up. You can see our chief engineer here, Owen, starting to take off the tops of the helium tanks. Those 2 of those big boys are going to be what goes into this balloon. So it's going to be huge. Not your average Party City Party City balloon. We then have Iris here, which is currently being attached to our secondary payload, our simulated 3U CubeSat, which is getting the final touches. We just installed our muon detectors. Solar panels are looking great. We're rolling. You have any comments, Sydney?
Why? Is it on higher? Is it on lower?
Let's see the action going on up here.
What's it like walking these things out here?
Oh yeah, so I think Will and I, who's the project manager, we're gonna make this a monthly occurrence, just a little date, walking 2 big helium tanks about a mile and a half. You know, that's pretty. You picked the right day, which we've had 2 beautiful days to launch on. It's kind of relaxing in the morning. So today the winds are coming from the north, so we'll be pushed to the south, which means that we might have a campus flyby, which will be great for the footage. The plan here is 2, so I will be. New game day footage right there. the plan is as well to hopefully actually give you guys some of the stream from the GoPros as you're lifting up, as I am controlling the two cameras we're launching via my phone, which is also where this live stream is coming from. So you guys might get some of that footage early. So Owen, how do we get the right amount of mass? How do we fill this up?
So this is filled to the desired lift mass. The payload weighs about 5.4 kilograms. This weighs about 8.3. So that'll give us an ascent rate of about 5 to 6 meters per second. So we're gonna fill it up until this bucket gets neutrally buoyant, and then we're gonna fill it up a bit more just for safety. And then we cut that cable, tie it off, cut the safety line, and then we're up in the air. It's exciting.
Very good. So last time we had a little too slow of a rise time. And okay, yeah, no, it was flawless execution. But we're learning, rapid iteration.
Yeah, there it is.
The people.
You're fired.
Well, the good thing is I wasn't hired as a cameraman, so hopefully for those of you who are watching on YouTube, this vertical or the vertical to horizontal adjustment is better for your laptops.
Yeah. We want to grab the chicken. Oh, yeah. Good.
Getting the action. All right, team member feature, Connor O'Brien. What is your position on the team?
I'm an engineer. I was working on the cones that are on the satellite
No,
over there.
sorry.
So what can you tell us about those
Tracking.
cones?
So those cones are going to amplify the light to a bunch of nano antennas. Professor Bernstein has a grant from NASA, and they're going to be detecting the infrared absorption at like the upper atmosphere.
So why are the cones shaped like that? Was that a specific reason, or did you just pick a good size that you liked?
Yeah, no, we ran simulations on it that we determined that was like the best amplification factor for the sunlight theory.
Yeah.
So then we built them to that size, lined them with some mylar to make it reflective. We're hoping for the best now.
Nice. So what? So Mylar is used for a lot of space things.
Yeah.
So it's good infrared, which is the thermal emission that we get. So it's nice that since we're trying to collect infrared rays, that we can also use Mylar for this purpose to act as essentially a reflector into our sensors. So we're big fans of Mylar at IrishSat. It's the official style guide. Yeah, hot glue and Mylar.
no electrical tape.
It's not rotating.
Oh, it's not rotating. Oh, thank you for the update. It's not rotating on YouTube, so I don't know where Owen's at, but someone needs to tell him. Video doesn't rotate on YouTube, so we're getting some live action here. Final tie-offs.
That's super.
Precision machine crossbar there featured. Then the
Call it precision. I actually,
Notre Dame
when I
Aerospace
machined it on the
Engineering
mill, I just kind of
Fabrication Laboratory.
yeah, Lindsay.
There's a look down the cones. So this camera here at the top, you can see actually has some solar filter. That was from the 2018 Great American Eclipse. So getting use out of those glasses. So there's a camera, a Raspberry Pi camera that is taking images of the sun, which is right behind us right now. And is sending data to the flight computer, which then captures that image and determines if it needs to move and orientate to the sun. So before we fly, we'll get some video to you guys of this thing booted up. It tracks the sun very well. The stick, carbon fiber stick coming out of Iris has the antenna attached to it. So we're using a light APRS, and we'll actually get some people from the communications team to talk a little bit about what they've done since the subscale launch in terms of communication. So Zach here is one of the communications leads.
Yeah.
So what can you tell us about the light APRS and what you guys have been working on?
So the Light APRS is a open source device, which means that we can modify the code and basically tell it to do and send whatever we want it to. So right now we have one on Icarus that'll be sending GPS, pressure, altitude, temperature, and then we also have one on Iris that will be sending all of the experimental infrared radiation data.
Very, very nice. So how is this different from what you guys did in the subscale launch? You guys have been putting in a lot of work.
So in the subscale launch, we just did the environmental data like GPS, temperature, pressure, altitude. But now we have the actual cones, so we can get real data from those sensors that we can send back as well.
Very nice.
Yes.
I haven't looked on this.
So, yeah. Okay. So basically, we did it in the reverse way. Yeah. There's not much we can do. But, how important are the soul phones? No, they're just. Yeah. Okay, let's. So there's.
And try to get it through. Why don't you do it slightly over? Like
That was an accident.
which one
I've
were
been
you-
working on this one. I'm just going through the test. Hard to test the logic because we didn't. Oh yeah, they're all ready. Is that ready? Good to go receiving? We haven't done a GPS yet. Swap records working.
It's right in the hole. Okay, cool. I can hide.
Drew, how's the cameras? How's it going on detectors?
Muon detectors are zip tied, so they they better be good. But
Very
they
good.
yeah they were turned on. We recorded the time. I think it's on your sheet there. And the cameras still need to be turned on external power, but they're all set. So yeah. Well, if you can give it me like T minus 5 minutes, that's when I'll turn on the cameras.
I mean, when you see the boom going up.
Okay, yeah, sounds good. So for the live stream, well, can you tell us your role and what you're doing here today?
Sure. Well, my role is really just whatever needs to get done. But right now, I'm working through the three-flight checklist that we have.
Oh yeah,
The idea
let's take a
is
look at that
essentially
checklist.
we have a lot of different components and different systems that are involved in the launch, and so we have to make sure that everything's ready before we actually. Because the last thing we need is to let go and then realize we've got to.
Ah, that'd be terrible.
We're going through and making sure everything's ready.
Checklist man.
All right. Yep.
Get some beeps of the aliens talking to us.
It might be. And I really don't know. Getting a lot of transmission.
Okay, now we're good. So contact if you want. That's the use.
What's that?
If you don't want to keep going, also still.
Oh, it's like it's not closed, or it's.
They're on the other side of.
Oh yeah, that's.
So last over the side, over the top of.
Yeah, we should probably close this now.
Like this.
Let me get connection to this camera, and then okay, live stream. You might lose some video here, but it's gonna be for a good cause. We're getting the GoPros working on the Icarus payload.
I don't know.
Will this be dropped back down at all?
Huh?
Yeah, this will be dropped back down in a sec, right?
Yes.
Okay.
And then we're gonna turn it on.
We'll do that when they drop it back down. Oh, we can do this one though right now. So staying ahead of the team here. Yeah, that's great. I will. I'm gonna get connection and probably turn it on then before we go. So. Okay, so we're back. You guys are getting a live stream of the GoPro. So this is one of the two views that we'll have during the entire flight. See. Yeah. So right now the camera module is being completely closed shut. So actually the view a little bit. Can you move it over to the left? Yeah. Yeah, you can tie it right there. Great.
All right. Thank you for being honest.
Looking good. Oh, Professor Howard, thanks for giving us the notification that the mute was off. So, or the the mute was on. Now, now the mute is off. Lindsay, can you debrief what we were just doing there?
What we just went down. Significant amount of knot tying.
What type of knots are you using?
Oh, it's a top line hitch actually.
Whoa.
Yeah, I know it's a knot. It's top line hitch, but then we have to super glue it. So it doesn't come undone. Super convenient because we pre-marked this time all of the lengths so that nothing's curvy. But
Nice.
the slip knot is helpful because then we can adjust the lengths right up until the beginning of launch.
Very
Should
nice.
be all good now. All the pillar trim is connected.
Knots aren't coming undone. A big gust of wind, they just unravel. Oh, that's the super glue story. Perfect. Amazing.
So now they're turning on Iris.
Wow, so we should see a little.
Its final touches.
Oh yeah, let's take a look at this. This is looking good. If NASA's watching this, we got a 3U CubeSat ready to launch. So just let us know when.
Okay. Well, hey Lindsay, no, that shouldn't be a problem. So if it's from above, it's now wrapped around.
Yeah, there's still some more that are not.
Well,
They're just.
these are not good, so I can fix that. Now I noticed that on another one. So we can fix that. Yeah, fix that.
Yeah.
So I'm checking around. Yep. From number 5? Yeah, I'll just get this one.
Oh, there's a simpler fix.
Okay, one.
What? Oh no. Yeah, if you can't hear it on the audio, the wind is really picking up here, which was similar conditions that we had for the subscale. It's all right, but it will drift our balloon a little bit further when it's in lower altitudes, and also makes the balloon fill quite a challenge. But we're prepared. We've thought this through. So how we discussed what we're going to do to help fill the balloon a little bit easier. So can you break this down for us?
Sure. So the biggest thing is making sure we have tall people.
Tall people.
Because as the balloon inflates, it gets higher up, and then we need to make sure
Harder.
that the balloon is not tilting as the wind hits it, and it hits the boom, and then that would very likely pop it.
Oof.
And so we need to make sure that as it's still not fully inflated, it's kind of a little more wobbly.
Mm.
And so we want to make sure we have people there to support it, make sure it doesn't tip over.
Gotcha. So key to tall people.
Tall people.
All right. So if you're tall and watching this stream, feel free to come by. We need some help.
Stop by the next 10 minutes. That'd be great.
Oh, that's such a good idea. Yeah.
So here are these great knots that Lindsay has been tying. Really good. Team meeting.
Inflating the balloon. Same process as last time. We're inflating it until the bucket gets lifted. We're gonna cut the line of the bucket. We're gonna get the safety line taut. We'll then cut the safety line. We need 4 people.
That's going down.
On the
It's going down right
booms.
now. Man.
We're gonna same as last time.
That's
Raise them
that
up.
one's set.
We'll need another 4 people on this, ready to, like, once it's in tension, then we're gonna hold it, and then finally we'll have another person down low, ready as we start walking the lines up to just hold it by this, and then they will lock it with the wind and let it go. All right. So I'm not gonna be paying attention. So everyone, make sure that there is a person on next.
Ooh, that's a sun lock. Even behind the clouds. Oh, maybe it's looking for it again. It's okay. We're gonna be above the clouds in about 3 minutes. So
No. That would be funny.
is that precision super glue going on the knots?
Oh yeah, want to see the crazy part? Okay, we're gonna accelerate the process.
Whoa.
If only our viewers could smell the process.
If only they could smell the activation going down.
Oh yeah, that is.
Now,
Pungent.
now the real question is, did Lindsay just?
No.
She didn't. It's
So
fine.
can you? What's the acceleration that's going on? Are you using some?
Electrical engineer. I'm not going to longer chemistry. But
It works though.
it works. I think it has something to do with some bonds coming down.
Whoa.
Yeah. I'm taking biochem right now. So we would, oh yeah. Do we have chemical engineers on the team?
No, we do not. But we'd be happy to take some. They could tell us about the bonding agents.
Yeah, I can make something up though. Professor Novaya taught me about DNA today.
Oh, nice.
I think it's the DNA.
Yeah. All right, so we're gonna be going off video here, but the next time we get video, hopefully you're gonna be looking from our second GoPro, which is gonna be getting some of that action right there from our orientation system. All right, so sorry we weren't able to give you that live feed from the Iris GoPro. It is recording though, so that footage will be with us later. Or what you're looking at right now is Owen controlling this massive balloon, and
It's gonna come off.
so I'm going to take you away from this view just briefly to show you how large this and it's really chaotic this balloon is getting here. Woo!
You're down there now. Oh boy.
So this is already much larger than our subscale balloon ever was. Are we on tank 2 or is this still tank 1? Is this tank 2 or 1? 2. This is tank 2. So we are minutes away from launch here. We've got both cameras rolling. We've got our active orientation system going. Muon detectors are running. Solar panel deployment is going. And we're only gonna be one hour behind the planned launch time. So that's that's pretty good.
Want to go get me a the wooden like sticks?
Yeah.
You want to
Good
get
into this. Sure.
Everyone up top is doing
So
Do you have any more of your 5-volt chargers for the batteries, for the cameras? Any extra ones on hand?
the batteries.
Like the battery modules with the converters.
Oh, yeah, I think so. What? One sec. All kinds of great teamwork going on here. A very dynamic process. Lots of things having to happen all at once. And the balloon is
Peter, this side.
Yes, on.
You got a soldering iron. I don't know if we have solder. Yep. Triple A's.
All right, we're going. Just wrap it up. Just wrap it up.
Keep your hands off.
everyone holding booms.
Yes, on
Right on the booms.
the
Cutting
thing.
this safety line. Cutting the safety line.
hey,
Watch it, watch it, watch it.
camera.
Grab the lines tighter. Grab the line. We're walking.
I don't think we're going to be tracking the sun. This carbon fiber is pretty close. So. Yeah, it's cool. It's happening. You know. Yeah, for first year. We did. We got subscale up. We got that thing up. We raised over 20 meters. Yeah, I mean, look for our first year, doing big projects. That was that. We took out 2 very big projects. Yeah. There's room to grow, obviously, from what happened there. But you know what? I'm still smiling.
Livestream on.
This is good.
Yeah.
We'll show her.
You on detectors.
We might be screwing up the comm system, but
Yeah. All right. Well, there's room to improve.
Sweet cheese car.
All right. Let's clean up.
okay.
Oh, what are you?
For everybody that was tuning in, we're this is Notre Dame IrishSat team 2021 signing off. Big launch. It's out there. In the sky. You guys probably can't see it, but it's up there, flawless. So we'll be updating you with the status and hopefully get you guys some good video. So till next time. Thank you.